Okay, this is the lessons learned from the fatal propylene explosion at Watson Grinding. This just happened in Texas in 2020. And the report came out from the Chemical Safety Board a couple days ago. So we'll go through this. So this is intended for supervisors and skilled workers, kind of like our facility supervisors and whatnot. Whereas the CSB report is mainly targeted towards a different audience of process safety management and whatnot. So this is going to be intended for, skilled workers, supervisors, the electricians and stuff like that. So first off, I want you guys to understand that so certainly not every facility is going to have 8,600 pounds of propylene, which is what caused this accident. Obviously our university doesn't, and none of our facilities do. But what I want you to focus on is the concepts of accident prevention, and so what unique issues that we have in that our facilities that will relate to this. So just want to give you the background of propylene. So it's a very extremely flammable gas. It has a lower explosive limit of about 2%, and it will easily ignite at room temperature. So once it reaches that 2% concentration in a space, any kind of spark will cause an explosion. So in this case, it's used for better performance in this accident anyway. And the oxypropylene gas mixture has better flammability properties than a typical oxyacetylene gas mix. So let's look at the timeline of this incident at Watson Grinding. So start off the end of the workday. So the coating supervisor didn't shut off the manual valve to the propylene tank at the end of the workday. So he was supposed to do that. That was part of his procedures. He did not do that. So at some point in the middle of the night, a gas hose detached from the coating robot, and propylene started to fill the space of the warehouse where all these coating robots were held. Next off, so the employees, couple employees entered the facility early in the morning to start the workday. One of the workers smelled some propylene gas, so that's kind of typical. They're fairly vaguely aware of propylene and the hazards, so they started to go investigate the problem. Next off, the worker went to investigate the gas smell from the warehouse, and he turned on the lights to the coating warehouse. Well, the static from the light actually ignited the explosive atmosphere in the warehouse, and it caused an explosion. So from that explosion, the entire warehouse was destroyed. The two workers died in the explosion. 2 more were injured, and 1 nearby resident was also killed. So pretty bit serious stuff. Obviously, we like I said, we don't have that kind of super dangerous atmosphere, but I want you to focus on the safety concepts more than anything else. So this is kind of what the coating warehouse looked like. It looked like a pretty well professional facility. So you can see each booth had their own little robot, and probably one of the things that they could have done. So each of these rooms was rated for the flammability protection from like the electrical code and stuff, but the warehouse was not. So likely what they're saying is that when they turned these lights on, that created a spark, and that ignited the atmosphere in the building, which caused the explosion. So the aftermath kind of speaks for itself. You can see like those it's pretty bad. So there's another photo of right there, and basically the whole company is just gone. So they did file bankruptcy. So 3 people died, 2 more injured, and a lot of damage to not only warehouse but some surrounding buildings in the area too. So what are some lessons that were learned from this incident? First of all, the supervisor deviated from his safety procedures. So the supervisor failed to close the manual valve at the end of the workday, and he kind of said that it was because it caused a slow startup for the start of the next workday. So he was kind of putting efficiency ahead of safety, kind of cutting corners, and really that caused this explosion, because when that hose popped off, if the valve was closed at the source, then there would not have been gas flowing into the warehouse. So the Compressed Gas Association also recommends closing the valves at the end of work or the end of the workday. Kind of same thing goes with the American Welding Society. A lot of different people say this basically, right? So if you're in your garage welding, you wouldn't leave your torches hooked up to the tanks. You wouldn't leave those open. You'd close them after you're done, open them when you're started. That kind of concept still applies even when you scale it up to this big of a process. So kind of here's what happened. So they had a big propylene storage tank. They had two different manual valves right next to the tank and a remote shut-off valve. And then that went through some piping to the warehouse to the different robots. An example of robot, there was a manual shut-off valve at the robot and a pressure regulator and then a remote shut-off valve, and then it went to a robot. So that's kind of basically what the supervisor should have did at the end of the day is went and shut off one of these manual valves, at 5 o'clock or whenever, open them the next morning, and that way, if there was a leak over here, it would have purged what was in the system and not the entire contents of the propylene storage tank. So the other issue was the improperly crimped hose. So they removed the factory crimp and installed a new one on their own. So at some point, an untrained worker didn't really do this correctly, and it led to the hose popping off because the whole system was pressurized. So we kind of want to emphasize that take the time to get properly trained to do all of this stuff, and especially the more hazardous the situation, warrants more training. And attention to detail is very applicable in this case. So so kind of here's what happened. The hose kind of just popped off right here. This is the manual shut-off valve, and this is where they made their own connection rather than a factory connection. So you can see right here on the left, this is what a typical factory connection looks like. On the right, this is, they use forensic analysis at the end of the accident. So this is the actual hose from the accident. You can kind of see that the ridges show that it's not crimped correctly, and so that's probably what caused it to pop off. So again, you want to. A lot of this stuff is very technical, so attention to detail would have helped here in this scenario. So the second thing they did, they used the wrong type of hose. They used a Type R welding hose, and this type of hose degrades in certain gases. These are only used for acetylene. So what they should have used is the Type T welding hose. So again, this idea is like you got to take the time to research the correct standards. There's whole bunches of standards out there, and make sure you're using the correct equipment for the correct application, and it expands. So the bigger the hazard, the larger the scale, the more attention to detail to this kind of stuff you have to do. So, and you got to keep up to date on changing standards. This standard actually came out in 1990, so it's still, it's a established standard. So, and then again, don't assume anything. So, for example, they probably assume that, okay, welding hose is welding hose, and they did not realize that when working with different gases and stuff, it has different hazards associated with it. So this is from Parker Industrial Hose, so grade R and RM welding hose. So why are the grades R and RM for acetylene only? So for many years, the prevalent fuel gas in the industry was acetylene. Acetylene has little or no adverse effect on rubber, therefore no requirements for fuel gas compatibility were initially specified in the RMA CGA IP7 standard. So due to enhanced performance or reduced costs, different types of fuel gases such as propane, natural gas, MAP, propylene, and hydrogen became popular. So many of these fuel gases are detrimental to certain types of rubber. So with the use of these fuel gases, combining the wrong hose and fuel could lead to a premature hose failure, property damage, and personal injury. So kind of just like what these experts are saying. So had Watson Grinding had a technical person on staff, even one of the workers, the supervisor, anybody that kind of understood this standard, a welder or anything, they could have kind of warned of the different types of hoses. So you really want to be knowledgeable in your specific industry and continue to learn about these new standards, especially as the industry changes. So right back in 1990, acetylene was prominently used. Now it's kind of more other things. So you just know that all chemicals are different and have different properties. In this case, the propylene degraded the rubber in the acetylene only hose. So the other thing is they changed the original design of the process. So originally there was a hard copper line installed, allowing for only one point of failure, going from the manual shutoff valve to the pressure regulator to the remote shutoff valve for each of the coating robots. So by introducing the flexible line, you're adding 4 more points of failure, because obviously the flexible lines are less rigid and less reliable than the hard copper lines. So don't just assume that you can improve upon the engineered design, because the engineering design process goes through several different steps and meetings and all sorts of highly technical stuff to come to the right conclusion. So don't assume that you can just improve upon it when you're going to change something. So kind of here's a diagram of the coating robots. So this is coming in from the main propylene feed. And so you have the manual shutoff valve. This is how it was originally here on the left. And you had copper tubing, hard copper line going from the shutoff valve to the regulator and then to a remote shutoff valve. And then from the remote shutoff valve to the robot, there was flexible line. And I'm not sure if this was the type R or the type T, but they rechanged this. And by removing this hard copper line, you're adding 2 points where the hose could kind of pop off at each point. So you're adding more points of failure. The other issue is they probably should have closed off these manual shutoff valves at the end of each day. They're kind of placed high up at the top of the roof. So they were relying just on this remote shutoff valve to work. So they're taking 1 point of failure, and you're adding 4 more to it. And just probabilistically, you're just increasing the amount of failures. So the other issue they had defeated safety devices. So there was automated safety systems that were non-functioning. They hadn't been functioning for a while. And it was officially reported that the safety systems were non-functioning. And then here's the big kicker here. Nothing was done about it. So the alarm system included gas detections, automatic remote shutoffs of the polypropylene at the feed tank, and then it started an automatic exhaust fan. So if it detected a leak, it would do all of these things. So, and they failed the issues were reported and they failed to act on these issues. So several years prior to the incident, Watson Grinding disabled the safety function of its automated gas detection alarm, exhaust fan startup, and gas shutoff system, essentially disconnecting it from the computer control system. And that should have automatically triggered the closure of the remote shutoff valve at the propylene storage tank. So gas sensors calibration contractors visited the Watson Grinding Coating building in 2013, 2016, and 2019, all raising the concerns in writing that the gas detection system was disconnected from the computer system. So Watson Grinding management also had a discussion 2 weeks prior to the incident that the booth's gas detections were not connected and needed to be fixed. However, they didn't do anything prior to the incident. So again, the incident happened in 2020. So, several years went by before they actually addressed this issue. So again and again and again, it was reported that these safety systems weren't working and nothing was done about it. So especially that they were written reports. So this is kind of a failure of the upper management. So you can do, as a supervisor, you can put pressure on upper management and safety that's saying, so be knowledgeable in the process and say, these safety systems are important and we need to do something about it. And at some point, if they would have budgeted to have these safety systems issued, they would probably still have a company because it wouldn't have exploded. So again, knowledge of the process. So workers and the supervisors should be knowledgeable of where they're working, as and become the experts in each area. And they could have prevented the potential explosive atmosphere of the propylene if they're knowledgeable about propylene and took that time. So again, this is not the best solution, but it's obviously the simplest. If they had just kept the exhaust fans on 24/7, then even if there was a release, the atmosphere wouldn't have been explosive. So coming up with simple solutions also could have prevented this. You can't always control what upper management wants, but you can control the hazards that you are in control of. So this kind of leads into the domino concept. So basically, an accident is a series of events that leads to an incident. So removing one of these dominoes, if you imagine dominoes stacked up, removing one of the dominoes in the chain will prevent an accident. So what does that mean? So here's the different accidents. So if we knock over one of the dominoes, will lead to an incident. If we remove one, and then let's say these 3 dominoes will fall, but this domino will still be standing, so no accident will happen. In this case, a deadly explosion. So we can kind of look at this. So the facility, lacking facility design. So the building was not up to the electrical code for a potential explosive atmosphere. So if it was engineered to have an explosive rated area, then when the worker turned the lights on, the building would not have exploded. So obviously there's some things we cannot control. As supervisors, as skilled workers, you cannot control what the building is. You can maybe input what you want, but the other thing is, poor upper management. Like, we can't really control that, but basically not approving the repairs for the safety system made it so there was no detection device. If the workers showed up and the alarm was blaring, they may not have went in, or they could have, the other thing is, you have a bad safety management program. So if there was no evacuation plan, there was no evacuation plan for the building if they heard audible alarms, or even if they smelled propylene. So not everything we can control. Obviously, this right here would probably be my role, the safety management program. So, but I don't control how the buildings were built. You can kind of have input, but so I don't control those people. But what we can control, right, is if I'm the supervisor, I can follow the procedures and shut off the valve daily at the end of work and turn it on. So obviously that's one of the easier things is not cutting corners and shutting the valve off at the end of the day. So that is something, like, if you're a supervisor in tasks in dangerous situations, that's something you absolutely can't control. The other thing is there is an aspect of kind of the worker shortcomings. So they fail to adequately inspect the robots for potential faults and mechanical integrity. So if they went in and inspected the hoses and kind of gave them a tug and looked for dry rot and everything, they could have potentially caught that there was an issue with the welding robot. So maybe they could have figured out that, hey, this is not the right hose for this situation. We need grade T welding hose, and we have grade R, so this is only for acetylene. Or they could have visually inspected the hoses and saw that, well, this hose is kind of degrading. And obviously that's hard to tell. The other thing that potentially could have done is, having a remote shut-off valve for each specific robot versus the one just at the propane tank. And there's a ton of different things that could have prevented this incident. But basically, by one person removing their issue and making it safer, the explosion might not have happened. So we can kind of look at this more in depth for this specific incident. So like I said, removing one of these issues could have prevented the explosion. You can kind of think of each one of these as a domino. So right in the end, there was 3 people that died and a whole bunch of property damage that happened. So what could we remove to do this? So there's some things you can't control. So right, the members of the public present, obviously, like if I was a worker, I did not choose where my workplace was built. That's a thing for zoning, whatever. Same with like oxygen inside the building. Obviously, there's going to be oxygen to make an oxygen-rich atmosphere that could cause an explosion. So we can't control those things. But how could we prevent the explosion in the building? How could we prevent workers that are present? So kind of this is, a good emergency response plan would have led to an evacuation if there was a release, and that would mean that there would be no workers present. So you would have saved 2 lives that way. Obviously, the public person would still be in their house, so that can be avoided. But how could we prevent the explosion? So, right, the worker turned on the light and it started a spark. We could put in spark-proof lighting if we're in a flammable area. So obviously that doesn't apply to us, but there is issues where this could apply in your specific situation. So the other thing is, how could we prevent the accumulation inside the coating building? So we could leave the fans on 24/7. These are the automated safety systems. We can make sure that the automated safety systems are actually working correctly, and we do that by inspections, testing, and if you have something sit for 10 years, especially electronics, it's probably not going to work reliably at all times. So they need to be tested and checked to make sure they are functioning, especially critical safety infrastructure. So the other thing, the manual shutoff valve was not closed, so that's kind of on the supervisor. Could the supervisor manually shut off each individual coating robot at the end of the day as well? Yeah, that is something they could do. They could put in policies in place to say only turn on the robot when it's actually coating, and then once it's done coating, turn it off. So all sorts of things they could do, but definitely they should have shut off the valve. So when you have this critical procedure for very hazardous issues, you want to make sure that you're following these things and not cutting corners. So the propylene hose disconnected, so it was degraded, right? So the wrong type of material. So you want to be very knowledgeable. So all of this stuff, be knowledgeable of the codes, the electrical codes, the fire codes, all sorts of codes and standards, and be knowledgeable with what you're doing and what you replace things with, right? So you wouldn't put the wrong size tire on your car and drive down the freeway. So you want to make sure you're using the correct stuff when you're fixing things and changing stuff. So right, so they could have, so the hose replaced the copper tubing. So if they replace the tubing, if they replace the bad tubing with new copper tubing or whatnot, they changed the design, and by doing so, that could have led to this issue. So again, they changed the factory crimp to one they did on site. So likely they didn't have someone who was well trained enough to know how to do this. And like I said, so like this is a higher hazard area than probably what we're typically used to. But if you don't, so let's say like you're fixing a pipe and the pipe isn't fixed correctly, that may cause a water leak rather than an explosion. We still don't want a water leak, right? And then the safety systems. So the process safety management program, that kind of be more my area. So it wouldn't be something that as a supervisor or worker you would do, but know that like any one of these dominoes could have been pulled out and prevented this explosion from happening. So in conclusion, this accident was definitely preventable, and so removing one of those issues could have had prevented that explosion. So I want to ask you, how can you apply these concepts to your day-to-day functions, and what specific issues you have on a day-to-day basis, and what can you do to address the hazards unique to your specific processes? So not all of us are going to be working with super flammable gases. That's okay. But what can we do to prevent accidents from happening? So, all right, here's some references. This is the CSB investigation report. It came out a couple of days ago. This is about the welding hoses, and then this is about propylene. So thank you for